Hello, welcome back to making a mini Rust in Rust. This is video 8 and we have a very basic programming language-ish thing working, right? We can add up two numbers, say 8 and 13. And this is the program that we pass in to our language. Oh, and I'm just running, I should be running it like cargo run here, but you get the idea. You pass in two numbers. And we're printing out, I mean, it's got the type and stuff information in there, but basically the number that is the result of adding up these numbers is calculated by our program and printed out again. So we have like a working programming language in some sense. We've done test-driven development, so we've got tests around this very limited piece of functionality that we've implemented, and literally like one character different and things go wrong, like if we miss spaces out then. So there's loads more to do before this is in any way like a robust or good language, even for adding up integers, let alone anything else. But yeah, we've got test passing, so now is the time to refactor, and we've identified quite a few things that aren't quite right about the way our code works. And let's start with looking at the evaluator, because this is where it all became clear. So when we're evaluating this like a sum, we came up with some insights, which is basically in our syntax tree. In our syntax tree, we have this idea of a leaf, which is like just a single piece of information. I almost had the word that you can sometimes use to say that. Oh, it's gone again. Yeah, so we have this leaf node in our tree. Like sometimes trees are more complicated. Like when you're adding things up, it's like a tree structure with mini trees for the left-hand side and the right-hand side of the things you're adding up. But when you get down to one of those final things, we're calling it a leaf, and the leaf was holding on to a token. And actually, that doesn't make sense because some tokens are not suitable to be held in leaves. So let's look at the syntax tree that we have defined here. And so the operator, we'll leave that as a token for the moment, but that'll change soon. But the leaf shouldn't contain a token. It should contain what we might call a leaf token. Let's go with leaf token for now. So a leaf token is going to be itself an enum, but only certain types of thing can be a leaf token. And for the moment, so it's going to be basically a subset of the tokens. So the tokens we have defined here, and at the moment we only handle ints and operators, and basically leaf tokens are only going to be ints, because operators don't make sense as leaves. The operators have to be part of the tree structure of some kind. And then I guess here, we need to make this debug and partial eq. And I guess here we want an operator to not hold on to any token, because like 3 can't be used as an operator to combine other numbers. So this would be like an operator token, like this. And it's now making me think, is this somehow, should we get rid of the token enum and only have these things? But I'm thinking no, I'm thinking some types of token are going to be both, say, I don't know, like an operator token and a unary operator token. Maybe there might be overlaps. I don't think we're going to abolish tokens and only have leaf tokens and operator tokens. I don't think they partition the set of tokens to use mathematical language, but I might be wrong, so we might come back to that. So partitioning set just means you've broken it up into exact pieces. None of them overlap, and together they take up the whole set. So, yeah, what I'm trying to say is, I'm not sure that leaf tokens plus operator tokens plus whatever other types of token we have are going to be a non-overlapping set of things which make up the entire set of tokens. But we'll see. Okay, so we've got some errors. So the first error is oh gosh, this needs breaking up. There's too much of this, isn't it? So what we're doing here is we are partway in. Yeah, so we've found an integer, and we're saying that, like, that might be just a leaf on its own, or it might be some kind of operation. And so we get the next thing, and if there is some next thing, it must be an operator, or at least it's a candidate for being an operator, otherwise it's an error. And if it's not, then this is a leaf, right? There was just the number and no operator after it. So in this case, the original token that we found, it was a leaf token. I think maybe we should be passing a leaf token in here, because if it wasn't a leaf token, we've already got a problem, right? Yeah. So first of all, let's apply the refactoring that I did somewhere else, which was, instead of this if let and then else none, let us just question mark it with let token equal next question mark. And basically, if that's none, we immediately return none, and we don't have to do any of this other stuff. So we simplified ourselves a little bit there, I think. But now I think we need to convert this into a leaf token. Like, so we're going to have some kind of operation that can turn a token into a leaf token, which we'll have to write. And if it's not okay, I guess we're going to be else. Let else. How does let else work? Does it do this? I think it does. Or maybe we can just. Oh no, there we go. Yeah, else, and then some. We're going to be. It's just going to be some. No. Okay, right. Let's just do a standard if let, and then I'll. If my brain unfreezes on that, then we'll come back to it. But yeah, if this was. No. We need to just get the result, and then match on the result. Or in fact, we can just immediately match. So we're going to match on this try from. If that worked, and it is a leaf token, we carry on. Otherwise, so this will be okay of a leaf token. We do all this stuff. Otherwise, I think we just return the error. Right? If we find some kind of error from this try from, let's just say it's going to be a miet error, and it's all going to be fine. Oh, and it should be some, yeah. No, this whole thing needs wrapping in some, because we've already evaluated. We've already eliminated the possibility. Oh, we also need to finish the match, right? We've eliminated the possibility that there's nothing at all in this line, yeah. Which it's a good use for map, but No, it's not a good use for map, because we're going to pull more things from next inside somewhere like this, so it's no good. Yeah, okay. All right, so we need a try from for leaf token. It's a very straightforward one. We'll try from token. I think this is how this works for leaf token. Like this. And the error, okay, it does allow you to set an error type, which is good. It's going to be a, oh no, what is I think a Miette result returns an error report as the error type. So we'll see whether it lets us do that. And here it's basically, we match on the token. And if it's the right kind of thing, we return it. Should match on the value. If it's an int, then we return a leaf token with the number in it. And if it's an operator, I guess this should be okay of that. And otherwise it's an error. And I'm a bit worried about, can I change this to say Miette result of self to make that a bit more explicit? And then here, the problem here is I don't think we've got the information we need to build a Miette error report right here. I don't want to pass it in. In fact, I can't pass it in because it's a standard method. So yeah, I need to return some other much simpler type, which is just essentially, it's like not a leaf token error. Right? So, I mean, not leaf token. Something like that. Which I guess we've got to make. And maybe we could make this be some kind of self-color error. Maybe we can use this error or some crate like that, which I think we've already got, to make this be a useful error type. But for now, I think probably this is enough because we're immediately going to do something with this error when we get it back. So this is just such a long block of code. We really need to break it up soon. So where were we? We were doing a try from on the leaf token. And if we got an error, we need to do some kind of clever error handling in here. I guess as unexpected token, does that describe what we... I guess it is. Like it's basically a number and then something else that wasn't suitable to be an operator. Okay, so what's it complaining about here? So now we're matching on leaf token now. But there is only one type of thing that leaf token can be. So we don't have to deal with, oh yeah, so now we just, our error message description just moves to here. We don't have to handle the error case because there are no other things a leaf token can be other than an int for now. And we are returning a result, and we should be returning an option of result. But there's too many sums here. I think that's the problem, right? Yeah, okay, and then it's not expecting a leaf token to be passed in here, but it should be because we've confirmed that this is not just any old token, it's a leaf token. And I guess we shouldn't be calling it leaf token, we should be calling it, like what we're passing in here is the left-hand side. It's the first, we've passed one thing. It was a leaf token, which means that it could be part of an operation. So this we should call, no, I mean, it's only the left-hand side if there's more. Otherwise it's just the leaf token. So maybe this is okay. And then inside here, we find out whether there's any more. If there's not any more, we're done. And this is a leaf token. And we're done. So our first bit of refactoring is clean. And now the other half is, there is more, there's another operator here, and we match on this operator to figure out whether it's what type of token it is. So instead of that, I think what we should do is say let operator token. So this should be, this is like, this thing is a token which might be an operator, and we're going to say let operator token equal token dot, no, operator token try from again. So we're following the same pattern again. Operator token try from token. And if it all goes wrong, I think we can just bail out and say, oh no, we need to somehow map that error to something useful, the same as we did before. So how did we do this before? We matched, yeah, we matched, and we didn't actually use the E, so we can get rid of that. Yeah, so let's do the same thing as this. Match on the try from, like this. And there's going to be two cases. Either it's okay, and it is indeed an operator token, and we do stuff, or it's not, and we should return basically this error, like it's not, basically it's not a valid, oh no, that's wrong. Basically we want to say, hang on, this should have been an, yeah, we don't have an error message for this yet, but it's going to be very similar to this. Basically saying, if it wasn't like a plus or something after our number, we don't know what to do with it. So let's write something like, e.g. 3 is not valid. We wrote that somewhere, didn't we? So there must be something going on here. And then if we can take this, this chunk of code really needs its own function. It's really messing me up. Let's comment out this stuff for now because there's just too many errors everywhere. And we'll put that back in. Oh, here's the place where we said 3 is not valid syntax. So yeah, I guess, look, yeah, I was checking for an int explicitly. Yeah, so we've replaced that bit, so we can get rid of that. We've replaced it with something that just feels nicer. And oh, we haven't implemented try from yet. We need to do that. But also then we need to say self dot, it's like rest of operation, isn't it, that we need to do now? It's like operation right hand side, something like that. And we need to pass into it the leaf token, which is left hand side, leaf token, which is the left hand side, and operator token, which is the operator token we just found. And that's going to be, it's going to be the contents of all that stuff that we've just done there. So function, what did I call it? Operator right hand side takes in, as always, a mutable reference to self. And like at some point we might not want to pass all this context through in this way. So left hand side, or let's just call it left, not LHS. So left is a leaf token. And it's a bit weird to me. Why am I not evaluating the expression on the left? So we'll need to get to that. And then operator is an operator token. And we're about to pull in like whatever the right hand side is from our input. And then, yeah, it's this stuff. So let's just copy the whole of that. And put it in our new function, and now it's going to be a bit easier to understand, right? Because it's broken up. So we can get rid of this, And yeah, what does operation right hand side return? I guess it returns the same as this other stuff. Yeah, I just suddenly got confused then about whether we were returning syntax trees or values, but we're in the parser, so it's all syntax trees. Okay, we still haven't implemented try from, so let's implement try from and then come back to this and see what this should. And this shouldn't be called right hand side; it should be called right. Let's not use abbreviations where we can avoid them. All right, so let's first of all do try from for operator token, because that error message is just constantly nagging at me. So impl try from for token for operator token, and fill in my stuff for me. And this is going to be a new special type called not operator token. I mean, we could share our error type between this and this, but let's just be as explicit as we can. It might one day it might help us when we're debugging if we see the actual explicit error type. And then to actually do this, it's basically match on value. Again, really dumb at this point, but this stuff will get filled in later. Basically, an integer is not an operator, so that's not operator token error, not operator token. Whereas an operator is an operator token. I guess this should be called literal. That's what we've been calling it. So this will be okay. Operator token, operator literal. So there's going to be a lot of quite boring code like this that we're going to need to do for these conversions, but it does mean we're really nice and safe in our types everywhere. Okay, so now we're looking at operation right hand side. Oh, why have I called it RHS when I said I wasn't going to use abbreviations? What am I going to call it? Operation right. It's not an argument, it's an operand. Operand. Let's call it right operand. Fine. So the right hand side should itself be not necessarily a leaf token, although for the moment we are just pulling in one thing. So for now, it should just be a leaf token. So fine. So we get hold of the right hand side. If there isn't anything, if there is no right hand side, then we've failed. So this else part is still valid, right? It's saying you can't just stop after a 3+. But if there is a right hand side, we get into here and we match what type it is. And if it's an operator, that's no good. So now this is another case of, this should be, for now, it should be a leaf token. Which is leaf token, try from, right. And we need to match on leaf token, and it's either going to be okay, it was a leaf token, like this, in which case I guess this is let's call it leaf right, shall we? It's the right hand thing, which is a leaf, so we're going to pass it in here, and left was already a leaf. We could just call this right, you see, that's the thing. And then error, it wasn't a suitable leaf token. Then we're going to do something like this. Yeah, in fact, this EG is still right. And what we do is approximately the same thing. Yeah, so I guess all we're doing here is before we were kind of manually saying, oh, that's not suitable as a leaf token, and giving an error. And now we're making it part of the type system. This try from thing makes it really clear and formal that that's what we're expecting to do. Now leaf right is a result. Oh, because I called it leaf token here. Let's call it right. Is that too confusing? Let's call it leaf right. Like so. So there's multiple things called leaf right here. This is a result, and then afterwards we've unwrapped that, so now it's an actual leaf token. That's either more confusing or less confusing, depending what you think. Okay, and now when we're the answer we expect is not a token, but a leaf token. Leaf token, like so. And this function doesn't exist, but this is, oh no, yeah, so we want that function to exist. Let's make ourselves a leaf token int function. For the same reason we made one before. Impl leaf token. Fun int takes in a literal, which is an ampersand str, returns self, which, oh hang on, that doesn't work like that, it works like this, but we did take ownership of the str. Yes, I did indeed mean this. All right, what's next? This should be an operator token of type. Well, at the moment, there's only one operator token type, which is, oh yeah, this is wrong, isn't it? I think this should be operator token plus. Let's rename it so that we don't have to do all the code ourselves. So yeah, we're going to be switching on what type of token it is. We're still going to hold on to the literal inside there because we might want it later. So this is going to be plus. And what's the problem there? Oh yeah, it should be, I guess, we're going to have a little plus function. And then this is going to be a leaf token again. Oops. It's going to be a leaf token. Same again. And we need to write this plus function on operator token. Impl operator token. Plus, which still takes in a literal. It's just a way of not having to write two owned everywhere. I think it's worth it to make our tests read a bit more clearly. Self plus literal dot two owned. And then it's going to moan at us that these are only used in tests. So we should make them... Oh, is it? I don't know if it is. Oh, it's just, there's a load of errors. All right, so what have we got left? Right, when we're evaluating, when we find a leaf, we used to pass in a token, but now we can simplify our code because we know it's a leaf token, not a lead token, don't know what that is. Now there is only one type of leaf token currently, which is an int one. There's no such thing as an operator leaf token because operators can't be leaves. So we've simplified our code a lot. We've got this weird match statement with only one arm in it now, but soon there'll be more arms, I guess. So And then on the operation, this is where things really get nice. This will be an operation token, operator token, which we'll import. And now this case doesn't exist anymore, where somehow we had an operator that didn't contain an operator token. But now this is going to be an operator token, and the types that you have inside here are plus or something else. We can't have this int case anymore. And we don't need to match on the literal anymore. This plus already tells us what operation we're doing. So we can go straight into looking at the types of left and right. Don't need this literal for now. So yeah, looking at the types of left and right and adding them up if they're the right types, and if not, eventually we'll have other arms here which say things like I can't add an I32 to a U size or something without you doing some conversions. So let's find all our warnings. Oh no, there's more errors, more errors. So these shouldn't be private, because we use them. What else? Oh, this, yeah, like I said, this is going to warn us about this. So let's for now just put these in go for test. And then if we ever do want to use them from outside, we can, I guess. I guess that's okay. It still annoys me. What else? That's it. No more warnings. Let's run the tests. If I can spell it right. All right. So we have refactored our types to be much more, to more represent only, like the best way to think about types is that error conditions should be impossible in the type system. So in this case, you can't have a leaf node that contains something that can never be a leaf node, like a plus. And you can't have an operator in an operation be something that can't be an operator. Like you can't use a number to combine together two strings or something like that. You have to use a plus or whatever. So I think that's a good refactoring. I think we're going to leave it there. And then we're going to leave ourselves a really knotty problem, which is probably going to be interesting, of next time figuring out how to make these error messages actually be nice. So we've got error messages for a parser where we have just hacked it in saying, oh, we don't know the source file name or the source code. And that's because we haven't passed down enough information into the parser. The tokens that we're passing in don't have any information about where in the code they're located. And we also don't have the source code at all, which needs to go here. And also, by the way, at some point, we're going to need to do things with files other than standard in. But in the meantime, our test pass, we can still add up numbers and they still get added up. But our code is much nicer now. So I hope you like a bit of refactoring. And next time, I hope you like a bit of even more error handling. See you then.